All right, hey there, Math 1070. You are now on section 5.3, which is really getting into some logarithm notes. And so I decided to make this video to try to explain some of the concepts, because sometimes when students see the word logarithm, they get kind of intimidated. So to start off, hopefully you realize on the left-hand side of my screen, right here that I've already written down, that's an exponential equation that says x equals a to the y power. So just to be reminded, x equals a is the base because a is to the y power. Okay, so a is the base over there in that equation. And so we can convert all exponential equations to logarithmic equations, okay? Which means log will be in the equation. Like if it's a logarithmic equation, log has to be in the equation, okay? So there's all these ways that teachers will try to teach you how to go from exponential to logarithmic, but here's my way of doing it still to this day. So whatever the base is in an exponential equation is going to be the same thing as the base in the logarithmic equation. So because over here the base was a, that means my little number is also my base, and it's going to also be a. I will literally skip a space, okay, and say that a logarithm will always equal an exponent. So take a look back over here at this equation. We clearly see that y is the exponent, therefore this will equal y, because a logarithm equals an exponent. You're going to hear me say that so many times in this video. Hopefully you won't forget it. So that means in that blank that I left, what's the only thing left to go there? It's just simply a x. So x equals a to the y power is an exponential equation. However, it is equivalent to logarithm base a of x equals y. So these two equations mean exactly the same thing, okay? So we're going to take a minute and practice this. We're going to convert exponential equations to logarithmic equations, okay? And there's examples of this in the PowerPoint. Exponential equations to log equations, okay? So if I start, for example, here's a true fact. We know that 3 to the second power equals 9. Like that is true. That is a exponential equation, okay? 3 to the second power equals 9. I can make that into a logarithmic equation. So I write the word log. I examine what's the base. So over here, the base is 3, which means my base over here is also going to be 3. I will skip a space, and I will write equals, and I know a logarithm equals an exponent. Over here, the exponent is 2, which means this is also going to equal 2. And so what goes in the blank space? The blank space is clearly going to be 9. So let's write something like this. What about 2 to the x power equals, let's say, 16. So I could rewrite that. That would be log base. Well, your base over here is 2, which means your base over here is also going to be 2. Skip a space equals the exponent. The exponent over here is x, which means this is also going to be x. And what's the only thing left? 16. So I go and put in a 16. Okay, so that's going from exponential to logarithmic. So you guessed it, the next thing I'm going to do is convert a log equation to an exponential equation. Okay. So let's get started. Let me move up and we'll go for it. So a log equation. Here's a log equation. Number 1. What about log? Let's do 32 equals 5. Okay? And this is a true equation. You may not realize it's a true equation because it's written in logarithmic form, but if you were to convert it to an exponential equation, you would realize it's a true equation. So let's do that. The base over here, the base is 2, which means my base is going to be 2. I have said several times already in this lesson that a logarithm equals an exponent. Well, this logarithm equals 5, which means my exponent is going to be 5. So 2 to the 5th power equals what's left, and what is left? 32. Oh, well, 2 to the 5th power does equal 32 because 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. So 2 to the 5th power does equal 32. That was a true equation, okay? So let's do one more. What about number 2? Let's do log of, let's say, 3. 81, and let's say I don't know what it equals. Okay, so let's rewrite it. Okay, so the base over here is 3. So over here, when I convert to an exponential equation, it's going to still be 3. My base is 3. A logarithm equals an exponent. Therefore, my exponent this time is actually going to be x. So 3 to the x power equals 81. And I kind of jumped ahead with this because not only can you convert this, which is exactly what we just did, you converted a logarithmic equation to an exponential equation, you can now solve this because you know that 3 to some power does equal 81. Think about it. 3 to the first power is 3. 3 to the second power, 3 to the first power equals 3. 3 to the second power equals 9. 3 to the third power equals 27. And 3 to the 4th power equals 81. So look at there. Obviously, x equals 4 because 3 to the 4th power equals 81. And so let me actually go on and show you exactly what my math lab is going to ask. So those were several examples of going back and forth from exponential to logarithmic or from logarithmic to exponential. But sometimes my math lab is going to ask you to evaluate a log. So evaluate, and let's do this, log of 5, 25. So they want you to tell me what this logarithm equals. So they don't actually like set it up as an equation because there's no equal sign, but you're going to. So log of 5 or log base 5 equals 25. Excuse me, I said that wrong. Log base 5 of 25 equals something. Well, you know when we don't know what something equals, we typically put an x. So we would rewrite this, guys, because unless you're freaking brilliant, most of you probably need to convert logarithms to exponentials. So my base over here is 5, which means my base over here is going to be 5. A logarithm equals an exponent, which means my exponent is going to be x. Equals what's left, which is 25. Well, this one's pretty much common knowledge because I would bet that every one of you in here know that x squared, or excuse me, 5 squared equals 25, which means x equals 2. So you just evaluated that particular logarithm. Okay. Now, there's plenty of more examples on my math lab, or not my math lab, but on the PowerPoint. But let me show you this one. Number 2, log base 5 equals, let's say, 90. Or of 90 equals something. Or equals, we don't know. So we write equals x. We don't know what it is. Okay? And so we set it up as a exponential equation. Okay? And we take a look. The base is 5, which means my base is going to be 5. The logarithm equals x, which means my exponent is going to be x, equals 90. So if you start doing the math, 5 to the first power equals 5. 5 to the second power equals 25. And 5 to the third power equals 125, guys. So hopefully you recognize that we bypassed 90. We went from 25 to 125. So I don't know what 5 to some power equals 90. Like, there is no way to figure this out. I do know it's going to be in between this and this, which means it'll be in between 2 and 3. But that's just having number sense, okay? And so when you can't convert logarithms by hand like we did in example 1 up here, you're going to use what we call the change of base formula, okay? Change of base formula. And there's official notes, like I said, on the PowerPoint. But the change of base formula, in the most simplistic way I can write it, is log of 90, because 90 is the larger number, divided by log of 5, the smaller number. And so you take your calculator, you need a calculator that has access to logarithms, and you say log 90 divided by log 5, I about said 10. And you get 2.7958. And I think my math lab, 88 actually. I think my math lab asked you to go 4 decimal places, which means you would go to the 4th, but you'd actually look at the 5th if we're rounding. So that would be 2.7959 after you round that 8 up due to the 8 that's beside it. So that would be my answer, and that is using the change of base formula. So that was just a quick example of how to go from logarithms, or go from exponentials to logs, and go from logs to exponential equations, and then how to evaluate logarithms and the change of base formula. And let me include this last little bit. I'm not positive if it comes up in this lesson or in the next one, but it can't hurt to go on and tell you. So last note, if I gave you log of 100 and I ask you to solve that, like tell me what this equals. We don't know. So you would need to convert it to an exponential equation. And I hope that you recognize that there is no base over here. For example, the base was 5 in this example. The base was 5 in this example. The base was 3 in this example, and so forth. But here I don't have a base. When I don't have a base in math class, there is an imaginary base 10. And so when I rewrite this, I would rewrite this as the base, which the base is base 10. The logarithm equals x, therefore the exponent is also x, equals what's left, 100. And then that's easy. We know that 10 to what power equals 100? 10 to the second power, which means x equals 2. So the moral of that story is when you